Q9173-1. When the temperature is minus 20 degrees Celsius at 15,000 feet indicated, you know that? A. Altimeters automatically compensate for temperature variations. B. The altimeter is indicating higher than true altitude. C. The altimeter is indicating lower than true altitude. The correct answer is B. When the temperature is minus 20 degrees Celsius at 15,000 feet indicated, the altimeter is indicating higher than the true altitude. This is because the altimeter is calibrated based on standard atmospheric conditions, where the temperature decreases at a certain rate with increasing altitude. However, if the actual temperature is colder than the standard temperature, as in this case, minus 20 degrees Celsius, the air density is higher than what the altimeter assumes. As a result, the altimeter will read higher than the true altitude. Therefore, the indicated altitude of 15,000 feet will correspond to a lower true altitude. 9172. If the ambient temperature is warmer than standard at FL 350, what is the density altitude compared to pressure altitude? A. Lower than pressure altitude. B. Higher than pressure altitude. C. Impossible to determine without information on possible inversion layers at lower altitudes. The correct answer is B. Pressure altitude is the altitude indicated on the altimeter when it is set to the standard sea level pressure of 29.92 inches of mercury, Hg. Density altitude, on the other hand, is the pressure altitude that has been corrected for non-standard temperature. When the temperature is warmer than the standard, the density altitude will be higher than the pressure altitude. In simpler terms, a higher temperature causes the air to be less dense, resulting in a higher density altitude compared to the pressure altitude. 9813. Given pressure altitude is 1,000 feet, true air temperature is 10 degrees Celsius. From the conditions given, the approximate density altitude is A. 1,000 feet mSL. B. 650 feet mSL. C. 450 feet mSL. The correct answer is B. The reason the approximate density altitude is 650 feet mSL is because density altitude is the pressure altitude corrected for non-standard temperature variations. In this scenario, the pressure altitude is given as 1,000 feet, which represents the altitude indicated on the altimeter after correcting for the local atmospheric pressure. However, the true air temperature is also provided as 10 degrees Celsius, which is warmer than the standard temperature at that altitude. Warmer temperatures result in decreased air density. As the temperature is warmer than standard, the density altitude will be lower than the pressure altitude. In this case, the approximate density altitude is determined to be 650 feet mSL, which means the aircraft will perform as if it were flying at an altitude of 650 feet above mean sea level in terms of air density and performance. 9163. En route at FL 270, the altimeter is set correctly. On descent, a pilot fails to set the local altimeter setting of 30.57. If the field elevation is 650 feet and the altimeter is functioning properly, what will it indicate upon landing? A. 585 feet. B. 1,300 feet. C. Sea level. The correct answer is C. In the United States, altimeters are always set to a standard sea level pressure of 29.92 inches of mercury, Hg, at and above 18,000 feet. This pressure is equivalent to approximately 1,000 feet of altitude. If the altimeter is not reset when descending into an area with a local altimeter setting of 30.57 inches of mercury, Hg, there will be an error of 650 feet. 30.57 minus 29.92 is equal to 0.65 equals 650 feet. When the altimeter setting is lower than the actual setting, the altimeter will indicate a lower altitude than the actual altitude. 9080. During an en route descent in a fixed thrust and fixed pitch attitude configuration, both the ram air input and drain hole of the pitot system become completely blocked by ice. What airspeed indication can be expected? A. Increase in indicated airspeed. B. Decrease in indicated airspeed. C. Indicated airspeed remains at the value prior to icing. The correct answer is B. The reason for the decrease in indicated airspeed is that when both the ram air input and drain hole of the pitot system become completely blocked by ice during an en route descent, the pitot system cannot accurately measure the dynamic pressure of the air flowing around the aircraft. The dynamic pressure is essential for determining the indicated airspeed. With the blockage of the ram air input and drain hole, the pitot system is unable to sense the increase in air pressure caused by the aircraft's motion through the air. As a result, the indicated airspeed will be affected, and it will typically show a decrease or even read 0 due to the lack of accurate dynamic pressure measurement. Therefore, option B is the correct answer, indicating a decrease in indicated airspeed when the pitot system is completely blocked by ice during an en route descent in a fixed thrust and fixed pitch attitude configuration.